Good morning, students. Now we'll see the multitone FM. Okay. Now there are any modulation technique. There are two types. One is single tone and another one is multitone. Now a single tone is nothing but a message signal consisting of only one frequency. The single tone which we already finished. Now this is the standard mathematical time domain equation of FM signal. Now for single tone, right? Now this is single tone FM, because message signal consisting of only one frequency FM, EFM. Am I right or not? So that is single tone FM. Now what is a multitone FM? What is the meaning of multitone? The message signal consisting of multiple frequencies. M of t, which is equal to A1 cos 2 pi F1 into t plus A2 cos 2 pi F2 into t and so on. Okay, message signal consisting of multiple frequencies is nothing but a multitone modulation, right? Now what is the standard FM signal? Now the standard FM signal, which is equal to AC cos 2 pi FCT plus 2 pi KF integral M of t dt. Now therefore S of t, which is equal to AC cos 2 pi FCT plus 2 pi KF integral. What is M of t? Multiple frequencies, multitone. So M of t equal to A1 cos 2 pi F1 into t dt plus 2 pi KF integral A2 cos 2 pi F2 into t dt. S of t, which is equal to AC cos 2 pi FCT plus 2 pi KF A1 integration is 2 pi F1 into sine 2 pi F1 into t plus 2 pi KF A2 integration means by 2 pi F2 into sine 2 pi F2 into t. So this is 2 pi cancel. S of t, which is equal to AC cos 2 pi FCT plus 2 pi cancel. KF into A1 is nothing but delta F by F1. Therefore this is beta 1 into sine 2 pi F1 into t plus beta 2 into sine 2 pi F2 into t. Now what is beta 1? Beta 1, which is equal to delta F by F1, which is equal to delta F is KF into A1 by F1. Beta 2, what is beta 2? Beta 2 equal to delta F by F2. What is delta F? KF into A2 by F2. Now this is beta 1 and beta 2. Now this is the multitone FM signal. Am I not? Now this is the multitone FM. AC cos 2 pi FCT plus beta 1 sin 2 pi F1 into t and so on. Okay. Multiple modulation indices is nothing but a wideband FM signal in multitone. Now see here, I just write here. Now this is a multitone FM signal, and this is also the multitone FM with the Bessel function quotient. Okay, this is a wideband FM in multitone, wideband FM in single tone, wideband FM in, this is the wideband FM signal in multitone, this is the wideband FM signal in single tone. Okay, therefore this is Bessel function quotient Jm of beta 1, Jn of beta 2 and cos 2 pi Fc, here NFM, Mfn plus NFF2 and so on. Okay, so this is the FM signal in multitone, because single tone which we already completed. Okay, note down this. Now see here, Now this is carrier after modulation. Now what is the carrier before modulation? The carrier before modulation, which is equal to AC cos of theta of t. Now which is nothing but we can know that AC cos 2 pi FCT plus phi. Now this is called as angle or argument. You know that. Okay. So while we are comparing these two, so I want to find a maximum frequency deviation. What is the maximum frequency deviation? That's why what is theta of t? This is the theta of t. Now the instantaneous angle after FM modulation, which is nothing but 2 pi FCT plus beta 1 into sine 2 pi F2 into t plus beta 2 sine 2 pi F2 into t. Now the angular frequency, which is nothing but d theta by dt, now which is nothing but 2 pi Fi, which is equal to d theta by dt. Therefore Fi, which is equal to 1 by 2 pi into differentiate the angle. So for finding the instantaneous frequency Fi, which is equal to 1 by 2 pi differentiation of d by dt of theta of t is 2 pi FCT plus beta 1 sine 2 pi F1 into t beta 2 sine 2 pi F2 into t. Right? Now therefore what is Fi? Fi, which is equal to 2 pi cancel Fc plus beta 1 2 pi cancel beta 1 F1 into t beta 1 F1 into derivation of sine is cos 2 pi F1 into t plus beta 2 F2 2 pi cancel cos 2 pi F2 into t. Now you know that Fi, which is equal to Fc plus delta f, right? A frequency deviation. Now this is delta f, this is delta f. Now what is delta f? Delta f, which is equal to beta 1 F1 cos 2 pi F1 into t plus beta 2 F2 into cos 2 pi F2 into t. This is delta f. Now maximum value, the maximum value occurs at t equal to 0. The maximum value will occur at t equal to 0. Therefore what is delta f maximum? Now the maximum frequency deviation is beta 1 F1, the maximum value of cos is 1. Now beta 2 F2. This is the maximum frequency deviation. This is the maximum frequency deviation. Now what is the modulation index beta? The modulation index beta, which is nothing but the maximum frequency deviation by Fm. Sorry, not Fm, omega. We can write omega. What is this? Maximum frequency deviation. Maximum frequency deviation by highest frequency present in the message signal. Highest frequency present in the message signal. Highest frequency present in the message signal. Maximum frequency deviation by highest frequency present in the message signal is the modulation index beta. Okay, not classroom workbook question number 1. Multitone FM classroom workbook question number 1 is an FM signal represented in time domain as, now I represented here, S of t, which is equal to an FM signal represented in time domain as 10 cos 2 pi into 10 power 6 into t plus 4 sin 2 pi into 10 power 3 into t plus 5 sin 2 sin 2 pi into 10 power 3 into t. Now an FM signal represented in time domain as this. Determine maximum frequency deviation. What is asking? Maximum frequency deviation, modulation index and bandwidth. Bandwidth and power, total power. These are the questions he is asking. But now you compare with the standard FM. Now see here, this is the standard FM signal. Now if you compare these two standard FM signals and compare AC equal to 10 volts and beta 1 equal to 4, F1 beta 1 equal to 4, F1 which is equal to 2 kilohertz, beta 2 which is equal to 2 and F2 which is equal to 1 kilohertz. Now what is the maximum frequency deviation? The maximum frequency deviation, which is nothing but beta 1 into F1, 4 into 2 kilo plus beta 2, 2 into F2 is 1 kilo. This is 10 kilohertz is the maximum frequency deviation. Then what is the modulation index beta? The modulation index beta is delta F maximum by omega. Omega is the highest frequency present in the message signal. Highest frequency present in the message signal is 2K, which is equal to 5, which is wideband FM. This is a wideband FM only. I am talking about a wideband FM. Beta is greater than 1. Then what is the bandwidth? The bandwidth, which is equal to 2 into beta plus 1 into omega, highest frequency present in the message signal. 2 into 5 plus 1 into omega is the highest frequency present in the message signal is 2 kilohertz. Therefore 6 into 2, 12 into 2, 24 kilohertz is the bandwidth. 24 kilohertz is the bandwidth. And power, what is the total power? The total power, which is equal to, now this is the wideband FM, the total power is unmodulated carrier power, AC square by R. So AC is 10 into 10 by 2 into R equal to 1. Therefore 50 watts is the total power. Now this is the wideband FM classroom workbook question number 1 in Multitone FM. Now classroom workbook question number 2. This is also very important question. Now I just explain clearly here. Frequencies F1 and F2. Frequencies F1 and F2 is applied to AM and FM modulator. The frequencies F1 and F2 is applied to AM and FM modulators with a modulation index of mu and a modulation index of beta for AM and FM. So what is asking? F1 and F2 is applied to AM modulator as well as FM modulator also. Okay. So this is applied to FM modulator also. So this is FC plus F2, FC plus F1, FC, and this is S of F of FM. Now this is AM and FM modulator. Now FC, spectral amplitude is AC by 2. Here AC mu1 by 4, AC mu2 by 4, right? And here the spectral amplitude is AC n equal to 0 here, right? See here m0 n0 means AC J0 of beta 1 into J0 of beta 2 spectral amplitude and reduced by a factor of 2, therefore this is 2. Now this is further m equal to 1 means AC J1 of beta 1, m equal to 1, n equal to 0, therefore J0 of beta 2, n equal to 0, J0 of beta 2 by 2 is the spectral amplitude. Now this is AC m0, so J0 of beta 1, n equal to 1, therefore J1 of beta 2 by 2. Now modulation index is mu, modulation index is beta, FC plus F1, FC plus F1, FC plus F2, FC. Now what he is asking is, now these two spectral components are same. FC plus F1 spectral amplitude, FC plus F2 spectral amplitude in AM and FM both are same. So can I equate these two? Yes. If these two are same, you can equate these two. So AC mu1 by 4, which is equal to AC J0 of beta 1 into J0 of beta, AC J1 of beta 1 into J0 of beta 2 by 2. So which results AC cancel, mu1 equal to 2 into J1 of beta 1 into J0 of beta 2. Now AC mu2 by 4, which is equal to AC J0 of beta 1 into J1 of beta 2 by 2. So which is nothing but 4 cancel, mu2 which is equal to 2 into J0 of beta 1 into J1 of beta 2. This is modulation index mu1 and mu2, right? Now he is asking the effective modulation index of AM in terms of Bessel function quotient. What is effective modulation index? The effective modulation index is nothing but square root of mu1 square plus mu2 square, or a total modulation index. Therefore square root of 4 J1 square of beta 1 into J0 square of beta 2 plus 4 into J0 square of beta 1 into J1 square of beta 2. So the total modulation index or effective modulation index, which is equal to 2 into root of J1 square of beta 1 into J0 square of beta 2 plus J0 square of beta 1 into J1 square of beta 2. This is the effective modulation index or total modulation index in terms of Bessel function coefficient. Now once again I explain the question, just concentrate here. This is multi-tone classroom workbook question number 2. Right? What he is asking is, this is an AM modulator, this is an FM modulator. Both the modulators are applied by F1 and F2 frequencies, F1 and F2 frequencies, and modulation index is mu1 and mu2. Modulation index is beta 1 and beta 2. Now what he is asking is the spectrum. See here, the concentrate on the spectral amplitude. Spectral amplitude is different and the normal amplitudes are different. Spectral amplitude is all are reduced by a factor of 2. The spectral amplitude in FC plus F1, FC plus F2, which is same in FM and AM. Therefore, FC plus F1 amplitude and FC plus FN amplitude in AM and FM, you should be equate. FC plus F2 spectral amplitude, FC plus F2 spectral amplitude in AM and FM, you both are equate, these two equations. So this is mu1 and mu2. But what is the final question? He is asking the effective modulation index of AM in terms of Bessel function coefficient. This is the effective modulation index of AM in terms of the Bessel function coefficient J0 and J1. Okay. Now this is a single tone FM and this is multi-tone FM, and this is the multi-tone FM analysis.